Okay, class, we're starting on section 5.5, dividing polynomials. Objective 1, use the quotient rule for exponents. We can simplify x to the fifth over x to the third by writing it out, which we have here. Now, we know in division, whenever you divide any number of variables that is not zero, when you have the numerator and the denominator is the same, you can simplify that out to 1. These simplify out to 1, these simplify out to 1, and these simplify out to 1. So what you would be left with in your numerator is x to the second power, and your denominator would be 1. So your final answer here would be x to the second power. Now, what can we conclude? We can conclude that if we have x to the fifth power over x to the third power, that we could keep the base the same and subtract the exponents. The numerator's exponent minus the denominator exponent, which gives us x to the second power. That is what we can conclude. Now, the quotient rule for exponents. If m and n are whole numbers and x is non-zero, then b to the m over b to the n is equal to b to the m minus n, which we just did up here. Now, it's just like with multiplication. Remember how in multiplication, if we took x squared times x to the third, we would keep the base and add our exponents, and that would give us x to the fifth. Now, we know division is the opposite operation of multiplication. So when you multiply, you add. Then when you divide, you will subtract. Now, let's go down here to example 1. We have 3 to the 20th over 3 to the 5th. So we would know we would keep our base as 3, and we would subtract the exponents. We would take 20 minus 5. Now 20 minus 5, we know is 15. So we would have 3 to the 15th power. Now we come here to b. We had x to the 6th over x squared. So we would have our base, which is x, and we would subtract that exponent. 6 minus 2, so we had x to the 4th power. Okay, now we come to c here. Now if you notice here, this is still one term divided by one term. So we would take this base here, which is a, and we would subtract our exponents. It would be 8 minus 6. Then we would take this base of b and subtract our exponents, which would be 5 minus 1. Now we would be left with a to the second power, b to the 4th power. Now we scroll down here. It says use the zero exponent rule. We know that 2 to the 3rd power is equal to, we know this is 2 times 2 times 2, which is 8. And then 2 to the 2nd power is 2 times 2, which is 4. And 2 to the 1st power is just 2. This suggests that 2 to the 0 power is 1. Now, let me show you what actually happens here. When you go down by one whole number, you could take this whole number, well, this answer divided by this answer was 8 divided by 4. That gave you 2. For every exponent that you go down one, you would just divide this by 2. So 2 to the 3rd gave us 8. To go down to 2 to the 2nd, we would take this 8 and then divide it by 2, and that would give us this answer. We would take this 4 and divide it by 2, and it would give us this answer. And then we would have to take 2 divided by 2, and it would give us this answer. So that is why it suggested that 2 to the 0 is 1. Now the zero exponent rule. For non-zero b, b to the 0 power is equal to 1. So it's saying basically that any number that is not 0, take it to the 0 power equals 1. So now we have 7 to the 0 power, which is 1. Now I'm going to skip b and go here to c. And this parenthesis here, 3y squared parenthesis to the 0 power is just 1. Now when we go to b here, remember what we learned in the other section. Whenever we have a negative and it's not in parentheses, that negative is not taken to the exponent. The only thing taken to the exponent is the value that's directly connected to the exponent. So in this case, only the 2 would be taken to the 0 power. So our final answer here would be -1. So even if that would have been a -5 to the 0 power, it still would end up equaling -1 because that negative is not taken to the exponent. Okay, now we go down here to objective 3. It says use the quotient to powers rule. We can simplify x to the third, well, I'm sorry, it'll be x divided by y in parentheses to the third power by writing it out. So what happens is you will write this fraction out 3 times multiplied by itself. So your numerator would be x to the third, your denominator would be y to the third. It says what can we conclude? We can conclude this here, that x over y to the third power is equal to, now we know that this exponent is assumed to be 1 with the x. So it'll be x to the 1 times 3. And then this y exponent is 1. So it'll be y to the 1 times 3. So that will give us x to the third over y to the third. Now, we come here. It says raising a quotient to a power. If a and b are real numbers and b is non-zero, then a over b to the n is equal to a to the n all over b to the n. Now, we come here. X over y in parentheses to the 5th power will give us x to the 5th over y to the 5th. Now we come here to b. We have x squared over 4 to the 3rd power. This is equal to x to the 2 times 3 all over 4 to the 3rd. So x to the 2 times 3 is x to the 6 all over 4 to the 3rd, which is 64. And that is your final answer for B. Now we come to C. Everything in this parenthesis is taken to the 5th power. So we can write that out. This would be -2 to the 5th. Well, actually, I'll leave that in parentheses. -2 to the 5th, a to the 7th times 5, all over b to the 4th times 5. Now, again, this is a 4, not a 9. Okay, so now, -2 to the 5th power is -32. And a to the 7 times 5 will give you a to the 35th. All over b to the 4 times 5 is b to the 20th. And that is it for C. Now we go down here to objective 4. It tells us to simplify. Now we have 6x to the 7th over 9x to the 4th. Now we know 6 and 9 both has what in common? You're correct. They both has 3 in common. So that will give us 2 over 3 because we'll divide both of these by 3. Now x to the 7th over x to the 4th, we know that that will give us x to the 7 minus 4. So this will give us 2x to the 3rd all over 3. And that is our final answer. Now we go here to B, 20 and 15. Now we know 20 and 15 both has 5 in common. So 20 divided by 5 is 4. 15 divided by 5 is 3. Now we have a to the 8th over a to the 6th. So that would be a to the 8 minus 6. And b to the 5th over b is b to the 5 minus 1. So this will give you 4a squared b to the 4th all over 3. And that is our final answer here. Now we come here to C. Now of course we know our final answer is going to be negative, so we could put our negative here. Now 18 and 36 both has 18 in common. So we know our denominator would be 2 here, our numerator would be 1. Now x to the 14th over x squared will give us x to the 14 minus 2. Okay, now our next thing, we will have y squared over y squared. We know these will simplify each other out. So now our final answer would be negative. We don't have to write the 1 here because we had x to the 12th all over 2. So that is our final answer. Remember, this is a 4. Now, we scroll down here. It says check polynomial division. Fill in the blanks with the following terms: quotient, dividend, and divisor. I took the liberty of filling these out already. So we have our quotient, which is our answer after we divide. Our divisor is our denominator, and our dividend is our numerator. So it tells us here, checking division of polynomials. To check a quotient in a division problem, multiply the divisor and the quotient. If this product is the dividend, the quotient is correct. So basically, they're telling you to take the denominator times the answer, and it should give you the numerator. So we have our divisor, we have our quotient, and we have our dividend. So 3 times 5 is 15. X squared times x cubed will give you x to the 5th. Y times y cubed is y to the 4th. And if you notice, both sides are equal to each other, so that is true. So now we scroll down here to objective 6. It says divide a polynomial by a monomial. First, we're going to multiply here. 3x squared times x squared will give us 3x to the 4th. And 3x squared times a minus 2x will give us minus 6x to the 3rd power. It says when we multiply or divide a monomial by a polynomial, we use the distributive property, which we just did. We distributed this 3x squared over both of these terms. Now with example 6, we would divide. We're going to divide each individual term by this denominator. Now, we'll bring down our 4. X squared divided by x, we know is x to the 2nd minus 1. And we know x divided by itself is 1. So this will give us 4x plus 1. Now we scroll down here. Dividing a polynomial that is not a monomial by a monomial. So what we have here is this here. We want to take this term here and divide it by all 3 of these terms. So we have 18x to the 6th all over 3x squared plus 6x to the 4th all over 3x squared plus 9x cubed all over 3x squared. Now we divide. 18 divided by 3 is 6. Now x to the 6 over x squared is x to the 6 minus 2 plus 6 divided by 3 is 2. And then we add x to the 4 minus 2 plus 9 divided by 3 is 3. And we add x to the 3 minus 2. Now, we have 6x to the 4th plus 2x squared plus 3x. And you could write the 1, but you don't need to write the 1. We could just leave it as 3x. So we have 6x to the 4th plus 2x squared plus 3x. And that's the final answer for A. Now we come to B. We divide each one of these terms by this 3xy. And remember, again, just to reiterate, our terms are always separated by addition or subtraction. So now, 12 divided by 3 is 4. X squared divided by x, we know that that's x to the 2 minus 1. And these y's simplify out. Plus 6 divided by 3 is 2. X squared divided by x is x to the 2 minus 1. And these y's simplify out. Minus 15 divided by 3 is 5. These x's simplify out. And y squared divided by y is y to the 2 minus 1. So we will have 4x plus 2x minus 5y. These are like terms, so we combine them. That will give us 6x minus 5y. And this is the final answer.